Okay, let's unpack this. We often talk about managing projects, right? As if it's just, setting a goal and hitting deadlines.
Yeah, it sounds simple on the surface.
But when you look at these massive undertakings like building a skyscraper or a new hospital wing, maybe a whole transit system, it's way beyond that.
Oh, absolutely. It's not just management. It's this rigorous, almost scientific process. It's been codified, really, by decades of professional practice.
So we're moving beyond just wishful thinking today. We're diving deep into the playbook, the very structured, academic, but also really practical playbook of construction project management.
That's right. And for anyone listening who needs to get a handle on the professional architecture behind these big endeavors,
Okay.
quickly, today is your comprehensive shortcut.
Where's our map coming from for this?
Our source materials is fascinating. It's lecture notes from Mizantepe University on construction project management. So it gives us this incredibly detailed, very structured view of the whole project life cycle. Yeah, from the basic definitions that, shape the field, all the way through this intricate six-stage journey, from the idea's birth to the final closeout.
So our mission today for you listening is to give you that deep understanding. We're going to define what a project is, get a grip on the competing constraints,
Those are always tricky.
right, and then walk through the professional architecture stage by stage, hitting all those crucial decision points. Let's start right at the foundation. What even is a project? How is it different from just, I don't know, running a business day to day?
Well, the standard definition, the one used globally by the Project Management Institute, or PMI, is critical. It really forces us to see the boundaries. They say a project is a temporary endeavor undertaken to create a unique product, service, or result.
Okay, temporary. That's the word that always seems to trip people up, doesn't it? We tend to mix up ongoing jobs with actual projects. So what's the fundamental difference there between temporary and, say, regular company operations?
It really comes down to permanence and repetition. Operations, they're the continuous day-to-day work needed just to keep the business running. Think routine accounting or manufacturing the same product over and over, or regular site maintenance.
Stuff that just keeps going.
Exactly. That work is designed to be repeatable, sustaining. Projects, though, they're finite. They absolutely must have a definite beginning and, crucially, a definite end.
They expire.
They expire,
Yeah.
either when the unique goal is met or sometimes when they're officially terminated for other reasons.
Yeah.
But they end.
And that idea of delivering a unique capital asset, that brings in a lot of the legal and financial weight, too, I imagine. The Federal Transit Administration, for instance, they frame it differently.
Yeah, they add a layer. They see a project not just as tasks, but as a group of interrelated work activities constrained by a specific scope, budget, and schedule, all aimed at delivering those capital assets needed to achieve strategic goals.
Right, so achieving the goal marks the finish line. That's why the stakes are often so incredibly high.
Precisely.
Yeah.
And to really grasp the nature of these high-stakes, time-bound things, we need to go beyond that simple definition and look at the seven defining attributes, like the DNA that confirms something is actually a project.
Okay, let's break down that DNA. What are the characteristics? The first one seems pretty straightforward. Unique purpose.
Right. It must have a clearly defined, non-generic objective. If we use the new house analogy, which is a great relatable construction project.
Everyone gets that.
Yeah. Many houses are built, sure, but the one you're managing is unique to that owner's specific demands, that particular site's geography, maybe the local regulations too. It's always one of a kind in some way.
Second, as you stressed, it has to be temporary.
Absolutely. Fixed beginning, fixed end.
Yeah.
For construction, that end date is often the key handover, right? The day the owners move in. That acts as this powerful, often non-negotiable anchor for the whole schedule.
Okay, the third attribute. This feels like where things get complicated and where a lot of friction probably happens. Progressive elaboration. The source calls it the aha concept.
Yes, and it's crucial. Projects rarely, if ever, start with every single technical detail finalized. They just can't, by their nature,
Why not?
because you don't know everything at the start.
Mm-hmm.
They begin broadly defined, and the specifics only become clearer, more refined over time. It happens iteratively. This is a critical insight for anyone listening. Successful project management means accepting that the definition will evolve.
And that's the tension, isn't it? The sponsor, the client, they want a firm budget and schedule really early on, maybe in stage one.
Always.
Yeah.
As early as possible.
But if the design hasn't gone through that progressive elaboration, if you haven't moved from, say, rough sketches to detailed technical drawings, that early budget is just
Speculative, right?
inherently speculative. And that clash between the need for early certainty and the reality of iterative design is a core pain point in management. It causes a lot of headaches.
Okay. Attribute 4. Requires resources. Yes, and often a resource is pulled from various places, specialized teams. It's not just materials, but people, specialized equipment, software. Construction is the perfect example.
Yeah.
You need structural engineers, plumbers, electricians, maybe landscape architects, interior designers,
All coordinated.
all coordinated into this temporary structure, this temporary team.
Fifth characteristic, a primary customer or sponsor.
Right. While any project has loads of interested parties, stakeholders, we'll call them, one entity has to provide the definitive direction and, crucially, the money, the funding. They're the ultimate backer, financially and strategically.
Got it. Sixth.
Sixth, a project has to be characterized by a sequence of complex, unique, and logically connected activities, all working towards that specific goal within defined limits. This complexity is what separates real project management from just, managing a to-do list.
And finally, number 7. This sounds like the big one. The reason we need project managers in the first place. A project involves uncertainty.
Absolutely.
Yeah.
Because every single project is unique. Even if you're building two seemingly identical houses side by side, there are always site-specific issues or market changes or something.
So that uniqueness makes it hard to pin everything down.
Exactly. It makes it tough to define objectives with absolute precision or estimate the exact time it'll take or nail down the final cost with 100% accuracy right at the start. That uncertainty is precisely why the job is so challenging.
Can you give an example of that uncertainty in action?
Sure. Think about external factors that could just derail the schedule. A vital supplier suddenly goes bankrupt. Or new government regulations change the building code mid-project. Or, geopolitical issues cause massive shortages and price spikes for key materials.
Stuff completely outside the project manager's direct control.
Right. That's the often unstable environment they have to operate within.
Okay, so summing up part 1. A project isn't just work. It's this deliberate, complex, time-bound, unique sequence of activities. And it operates under inherent risk with details that evolve over time. Now, how do managers try to contain and control all that risk and complexity? What's the framework?
We contain it, or try to, by mastering the boundaries. Every successful project manager has to, first and foremost, get a handle on the fundamental constraints. These are often called the triple constraint, 3 goals that are frequently competing with each other.
The classic triangle. We're talking scope, time, and cost. These 3 are always pushing and pulling against each other, right?
Right.
And managing the trade-offs between them is like the core job.
That idea of trade-off management is absolutely fundamental, yes. Scope defines the work, what unique result does the customer expect. Time is the detail, how long will it take? And cost is the budget, the resources needed.
And they're linked.
Intrinsically linked. If the client suddenly wants an increase in scope, you generally have to increase the time or the cost, or probably both. If they demand it faster, less time, then you either have to cut back the scope or accept a potentially huge increase in cost, maybe for overtime or expedited materials. That triangle is never static. It's always shifting.
It's a constant balancing act, a system of necessary compromises, really. But the Ms. Tepe notes, they stress that just hitting those 3 isn't always enough for real long-term success. There are other factors.
Exactly. They correctly point out we need to introduce at least 2 more critical factors.
Yeah.
Quality and risk.
Okay, so quality is, how good does it need to be?
Precisely. How good must the final product or service be to actually satisfy the customer's needs, both what they explicitly ask for and what they implicitly expect?
And risk.
Risk asks, how much uncertainty are we willing to live with? And crucially, what are we actively doing to mitigate that uncertainty? So balancing all 5, scope, time, cost, quality, and risk, that's true mastery needed in modern project management.
Okay, that makes sense. Now let's zoom out a bit. We've talked about a single project, but in the corporate world, you hear terms like project, program, and portfolio. They often get jumbled up, but they mean very different things strategically, right?
Oh, functionally, they are worlds apart. A project, as we said, is temporary, creates something unique. A program, however, is different. It's a group of related projects, all managed together in a coordinated way.
Related. Why group them? What's the benefit?
They're managed together specifically to get benefits and control that you just wouldn't get if you ran those projects as separate islands. There's usually a common strategic purpose linking them.
Okay, so give me an example.
Think about upgrading an entire national energy grid. It's a massive strategic change. It might involve dozens of individual but related projects like building new substations, upgrading transmission lines, installing new software. Managing them as a program allows for better resource allocation, risk management across the board, and ensures they all contribute to that single big goal.
And programs tend to last longer.
Much longer, typically. They achieve a beneficial change of a strategic nature, as the source says. They often span several years, reflecting that deep strategic investment.
And the program manager role is different too then, not just delivering one thing.
Very different. They're often called change agents. Their job is coordinating across multiple project teams, different functional groups within the company, suppliers, maybe even government agencies, all to make sure that overarching strategic change actually happens successfully.
Okay, project, program, now portfolio management. This sounds like the really high-level view.
It is. We take another massive step back here to the true corporate bird's eye perspective. Portfolios are collections of programs and projects that all support a specific business goal or objective.
And here's the crucial difference I need to remember. The projects and programs within a portfolio, they aren't necessarily related to each other technically.
That's the key takeaway. They might be completely independent in terms of what they produce. Think about that construction business example from the source material.
Right, the company with different units.
Yeah. A major construction firm might have, say, 3 different strategic business units. One doing retail developments like shopping centers, another building single-family homes, and a third focused on massive multifamily residential towers.
Okay.
Now, the projects within the single-family home unit, they might form a program because they share resources, target similar markets, maybe use common designs, so they're related.
But building houses is totally different from building a shopping mall.
Exactly. That single-family program is entirely independent, technically and operationally, from the retail shopping center development program.
Yet they all sit under the company's overall corporate portfolio. Why?
Because portfolio management is a different strategic discipline altogether. The main goal of the portfolio isn't about delivering a specific type of asset. It's about meeting the corporation's highest strategic goals, things like maximizing shareholder return, achieving a certain level of market penetration, or balancing risk across different market sectors.
So portfolio management is about picking the right mix.
Precisely. It's the act of identifying, prioritizing, authorizing, managing, and controlling this diverse collection of sometimes completely unrelated programs and projects, all at the same time, to hit those big, overarching business objectives. It's a job focused on capital allocation, balancing risk across different investments, and making sure everything aligns with the highest level strategy.
Okay, that clarifies the hierarchy nicely. We've defined the universe, we understand the constraints, and we've positioned the project within that larger corporate structure. Now let's get practical. How does this structured approach actually play out step by step in the real world of construction? This is where the life cycle really comes into focus.
Right, this is the core of the professional playbook we talked about. Every construction project, as the source material nicely puts it, is born, matures, carries through to old age, and expires. They follow this pretty discrete, largely sequential path through 6 distinct stages.
And before we jump into stage 1, there was that critical strategic insight you mentioned earlier. It seems really important. About bringing the builders in early.
Yes, it bears repeating because it often gets overlooked. Bringing the construction professionals, the people who will actually build the thing into the process during the earliest planning stages, it demonstrably saves money, often delivers the project sooner, definitely reduces conflicts down the line, and usually increases the overall quality.
Why is that? Is it tied to that progressive elaboration idea?
Absolutely. Because the builders understand constructability, material costs, sequencing. Their input during early design can prevent costly rework or unbuildable designs later on. Early collaboration is key.
Makes sense. Okay, let's map out these 6 stages then, starting with stage 1. Feasibility planning or initiation.
This stage is really owned by the client, the project owner. Before any real design work starts, they have to make 2 absolutely fundamental decisions that will shape the entire project's financial risk profile and how it's executed.
Okay, decision A is selection of the project delivery system. This sounds like how they structure the main contracts.
Exactly. How will the owners set up the relationship between the people who design the asset and the people who actually build it?
What are the main options?
Well, the traditional approach, often the most bureaucratic perhaps, is traditional design bid-build. Here, the owner first hires a designer, an architect, or engineer to create 100% fully detailed plans and specifications. Then, armed with those complete plans, the owner puts the project out to competitive bid and hires a separate general contractor to do the actual assembly based on those plans.
So design contract and construction contract are totally separate.
Completely separate entities, separate responsibilities. It clearly defines roles, but can sometimes lead to finger pointing if problems arise.
What's the alternative mentioned? Design build.
Right, design build, or sometimes called design construct. This streamlines things considerably. The owner executes a single contract with one organization that takes responsibility for both designing and constructing the project. Usually, it's for a fixed lump sum price.
So one throat to choke, so to speak.
Yeah. Well, yes. It minimizes the management burden on the owner, but it does require a huge amount of trust in that single design build firm because they control both design choices and construction execution.
Okay, that's the delivery system. What's decision B contract type? This is about how the builder gets paid.
Precisely. And this is crucial because it dictates who carries the financial risk. If the owner opts for a fixed price contract, also called lump sum, the contractor agrees to complete the entire scope of work for one specific firm price, no matter what their actual costs turn out to be.
So the cost risk is almost entirely on the contractor.
Pretty much. The owner gets budget certainty, which is attractive. But the potential downside is the contractor might be tempted to cut corners on quality later if their costs start unexpectedly rising just to protect their profit margin.
What are the other payment models?
You have unit prices. This is common in large infrastructure projects like roads or pipelines. Payment is based on measured quantities of specific work items installed, like cubic meters of concrete poured or linear feet of pipe laid at pre-agreed prices per unit.
So payment scales with the actual amount of work done.
Exactly. And then there's the reimbursed actual costs plus a fee model, sometimes called cost plus. Here, the owner basically pays the contractor for all their legitimate, documented costs, labor, materials, subcontracts, plus an agreed-upon fee, which is the contractor's profit. Sometimes there's a guaranteed maximum price, GMP, added as a cap.
This sounds like the owner takes on more cost risk.
They do. The owner pays the real bills, whatever they turn out to be,
Yeah.
up to the GMP if there is one. But the benefit is often complete transparency into the costs. This choice, fixed price, unit price, cost plus, fundamentally shapes the entire commercial relationship and the incentives for both sides.
Okay, foundational decisions made. Now we move into actually designing the thing. Stage 2, design development. This looks like it has 3 steps.
Yes, it's a structured process designed to handle that progressive elaboration we talked about. It moves from the general to the specific. First step, schematic design.
Schematic, like sketches. Conceptual.
Exactly. This is the high-level conceptual phase. The main goal here is to take the project's philosophy, the owner's objectives, the design brief, and translate that into a tangible design concept. You also need to secure initial development approval from local planning authorities at this stage.
What are they focusing on?
Big picture stuff. The site layout, the building's orientation, its overall size, shape, general appearance, how it functions internally, and making sure it complies with basic zoning and environmental rules. And crucially, the source notes. A value management appraisal should happen right here.
Value management. What's that?
It's basically asking, before we invest a ton of time and money detailing this concept, is this the most cost-effective and efficient way to achieve the client's actual functional goals? Are there smarter ways to design it to deliver the same value for less cost? It's a critical check early on.
Okay, after schematic comes preliminary design.
Right. Now we start getting more technical. This is a highly important stage because we begin making the critical technical decisions that really drive the project's cost, structure, and constructability.
Such as?
Things like evaluating different structural systems, steel frame versus concrete, for example, prioritizing specific construction techniques, selecting major material types, verifying performance requirements like energy efficiency targets.
So the look and feel get more defined, too.
Yes, the spatial solution, the floor plans, and the exterior design get developed much further, moving beyond basic sketches into real engineering concepts. And because these major systems and materials are now being chosen, it allows the team to prepare a much more accurate cost estimate than was possible back in stage 1. It refines that initial budget significantly.
And the final design step is final design. Sounds like where everything gets locked down.
That's exactly the aim. Full development and critically detailed coordination across all the different design disciplines: structural, mechanical, heating, ventilation, air conditioning, electrical, plumbing, maybe fire protection, IT infrastructure.
All have to fit together.
They all have to fit together seamlessly in the drawings and specifications. This stage also involves preparing all the final documentation needed to secure the actual building permit or approval.
So this is the complete blueprint.
It is. By the end of final design, all the major conceptual and technical decisions are locked in. The preliminary drawings are detailed into a complete, fully coordinated set of construction drawings. All the building materials, fixtures, finishes, equipment, everything is selected and specified in detail. The project is now considered fully designed and ready to be put out for pricing by contractors.
Okay, so we have the final design. Stage 3 sounds like pure paperwork. Tender contract document development.
It is largely about transformation, yes. Taking all that conceptual work, financial structuring, and detailed design effort and codifying it into this, well, often massive stack of official documents.
What's the main purpose here? Just getting it all written down.
Clarity and legality are paramount. These documents will legally form the basis of the construction contract itself. They allow the competitive contractor selection process, the tendering or bidding, to begin in the next stage. Any omissions, ambiguities, or contradictions in these documents, they will become sources of conflict and potentially litigation later on. Precision here is vital.
And what goes into these documents? It sounds like a lot.
It is extensive. Broadly, you have all the bidding information. That includes things like the formal invitation to bid, the detailed instructions to bidders, how to format their bid when it's due, evaluation criteria, and the bid form itself. Often this includes a bill of quantities, or BOQ.
Bill of quantities?
Yeah, that's an itemized list of all the work components and materials needed for the project, with estimated quantities. Contractors then price each item in the BOQ to arrive at their total bid price. It provides a common basis for pricing.
Okay, that's the bidding stuff. What about the actual contract?
That's the core contractual information. This covers the legal agreements. It includes the main agreement form itself, the general conditions of contract, standard clauses covering things like payment, insurance, disputes, maybe special conditions, project-specific modifications, the very detailed technical specifications.
Specifications, that's the written instructions.
Exactly. Detailed written instructions describing the quality of materials, standards of workmanship, testing requirements, how things must be installed or built. And, of course, the drawings, the final, coordinated set from the design phase.
Wow. That sounds incredibly complex to assemble without errors.
It is. The sheer volume and technical detail required are immense. That's why the source provides that simplified mnemonic, the ABCD rule, just to help remember the core contractual components. A for the agreement, B for the bill of quantities, C for the construction specification, and D for the drawings.
ABCD. That's helpful, because you can see how mistakes here could be disastrous.
Absolutely. Many construction projects actually run into major trouble, not during the physical building, but because of problems buried deep in these documents. Contradictory specifications, missing details, unclear instructions. Documentation mastery is a critical, often underestimated competence.
All right, the documents are pristine, hopefully. Now, stage 4, procurement. This is where we actually pick the contractor who's going to build it.
Correct. This is the formal qualification and selection process. The goal is to ensure the client gets the best advantage, considering both the price offered and the contractor's demonstrated efficiency and capability.
How is that usually done? What are the main ways to select them?
We generally rely on two major approaches. The most common in public works, and often private, is the competitive bid. Here, multiple potential contractors who are hopefully competent and capable are invited to submit offers based on those tender documents. The contract is then awarded to the bidder deemed most responsive based on a formal, usually predefined evaluation process.
Most responsive. Does that always mean cheapest?
Often, but not necessarily always. Sometimes technical scores or other factors are weighted, but a common refinement is the shortlisted bid process. In this case, the client first pre-qualifies a select group, maybe 3 to 5 firms, based on their known reputation, financial stability, and past performance on similar projects.
So they weed out the unqualified ones first.
Exactly. Then, the competition among this pre-qualified group focuses almost exclusively on the financial offer. In this scenario, yes, the lowest responsive price very often wins the work.
What's the other main approach besides competitive bidding? Negotiated bid.
Yes, this is quite different. Here, the client invites, negotiates terms with, and then awards the contract to a single specific contractor without any open competition.
Why would they do that? Seems less competitive.
It's usually reserved for specific situations. Maybe the project requires highly specialized services that only 1 or 2 firms can provide. Perhaps it involves proprietary technology owned by that contractor. Or sometimes, frankly, there might be a potential conflict of interest, like The client entity happens to be a major shareholder in the contracting firm, making negotiation more appropriate than open bidding.
Okay. And within bidding, there's this idea of timing the technical checks, pre-qualification versus post-qualification.
Right. This is about when you assess the bidder's technical ability separate from their price.
What's the strategic thinking behind choosing when to do that?
Well, pre-qualification means you assess and evaluate the bidder's technical proposals, their capability, proposed team, safety record, resources, methodology, before you even open their sealed financial offers.
Why do it that way?
The big advantage is it ensures only truly capable and qualified firms actually get to the pricing stage. It saves the client time later, as they don't waste effort evaluating low prices from potentially incompetent bidders. It significantly reduces the risk of awarding the contract to a firm that can't actually perform the work properly, even if they offered a temptingly low price.
Okay, so pre-qualification prioritizes capability and risk reduction upfront.
That's the idea. Post-qualification, on the other hand, means you open all the financial offers first, maybe identify the lowest bidder, and then you perform the detailed technical evaluation on that lowest bidder or maybe the lowest few.
What's the trade-off there? Seems riskier.
It prioritizes pure cost competition upfront. You see the lowest price immediately. But the risk, as you noted, is that the client might spend significant time and effort evaluating the technical proposal of a firm that ultimately gets disqualified for being incompetent or non-responsive simply because they submitted the lowest number. So post-qualification can sometimes be faster if the low bidder is qualified, but carries more risk if they aren't. It's a strategic choice based on the client's priorities, risk aversion versus speed and cost focus.
Okay, contractor selected, contract signed. We finally get to stage 5. Construction, implementation, and monitoring. This is where the dirt flies, right? The actual building happens.
This is indeed the physical action stage. It officially begins when the contractor gets possession of the site, and it typically ends when the project reaches what's called practical completion or substantial completion. And all the work during this stage is supposed to be executed strictly according to those contract documents we just talked about.
And planning doesn't stop just because building starts?
Oh, absolutely not. Planning is continuous and proactive throughout this stage. The source highlights 4 basic reasons why you keep planning, which really show its defensive nature. Planning is done constantly to eliminate or at least reduce uncertainty as new issues arise, to improve efficiency in how resources are used day to day, to maintain a clear understanding of the objectives as work progresses, and critically, to provide the essential baseline for all the monitoring and control activities.
Because the alternative is just chaos.
Pretty much. The alternative to continuous forward-looking planning is just constant firefighting. If you're only making decisions based on the crisis that blew up yesterday or relying solely on how things were done in the last job, you're not managing proactively. You're just reacting. That's crisis management, not the systematic, almost entrepreneurial process that modern, complex construction really demands.
Okay, so planning continues. What does implementation cover here?
Implementation is the action phase within this stage. It's taking all the steps needed to actually complete the work according to the plan outputs. This involves a huge amount of coordinating labor, materials, equipment, subcontractors. It requires strong leadership from the site management team. Ongoing team development is important too. Rigorous quality assurance checks against the specifications, generating regular progress reports, proactively procuring materials or equipment that have long lead times, and inevitably taking corrective actions when actual progress deviates from the plan.
And running alongside all that action is monitoring. This is the checking process.
Exactly. It's the constant checkup, measuring actual progress against the planned objectives, specifically looking for deviations or variances that might signal potential problems ahead, and then figuring out and taking the necessary corrective steps to get the project back on track.
What are they typically monitoring?
Traditionally, the focus is intense on those key constraints we discussed. Is the scope still being met? Is the project on schedule? Is it staying within budget? Is the quality meeting the required standards? Those are the big ones.
But the benefits go beyond just ticking boxes.
Definitely. Good monitoring does much more than just keep the project on track, on time, and on budget, although that's crucial. It's also vital for spotting new opportunities that might have emerged since the project started, for verifying that the work being done is actually producing the intended benefits for the client, and, very importantly, for identifying any unexpected consequences, positive or negative, that might be cropping up. This allows for regular adjustments to the plan and strategy based on real-time feedback. It's not just a historical scorecard. It's an active, forward-looking early warning and guidance system.
Okay, the building is up, mostly. We've reached stage 6, project closeout and commissioning. And we absolutely have to bring up that quote the source mentions here. Projects proceed smoothly until 95% complete, and then they remain at 95% forever. Why is this final stage notoriously difficult, even when the bulk of the physical work seems finished?
Ah, yes. It's a classic observation, and sadly, often true. It happens because there's often a failure of focus, maybe driven by administrative fatigue, and also a subtle shift in what needs doing. Contractors, and sometimes even the client team, can put too little emphasis and planning into this phase because the exciting part, the heavy construction, is mostly done.
The satisfaction isn't there anymore.
Perhaps. The job shifts dramatically from the tangible, visible progress of placing concrete and steel to the often tedious, detail-oriented process of final testing, fixing minor defects, and wading through a mountain of paperwork. It's a massive administrative hurdle that requires dedicated resources and management attention, just like pouring the foundation did. It needs to be properly programmed and budgeted for from the start.
So how does the source break down the tasks in this closeout stage?
It helpfully divides them into two critical categories. First, category A is completing the work, the final physical activities needed on site. Second, category B is closing out the project, which is mostly about the paperwork, documentation, and final contractual formalities.
Okay, let's look at category A, completing the work. What's involved physically at the very end?
This includes things like final testing and startup of all the building systems, especially complex ones like mechanical, heating, cooling, ventilation, electrical systems, plumbing, fire alarms, security systems. They all need rigorous commissioning to ensure they function correctly as designed.
Making sure everything actually works.
Exactly. It also includes the final thorough cleanup, not just sweeping, but detailed scouring, maybe carpet shampooing, window washing, polishing fixtures, everything needed to make the facility actually presentable and usable for the owner.
And then the lists. The dreaded punch lists.
Ah, yes, the lists begin. First, you typically have preliminary punch lists, sometimes called snagging lists or inspection lists. These are compiled, often by the architect or engineer during walkthroughs, to identify any remaining work items that are incomplete, defective, or not complying with the contract documents. Minor repairs, touch-ups, adjustments.
And the contractor fixes those.
Ideally, yes. Once the contractor believes they've addressed everything on that preliminary list, they'll notify the owner and designer that the project is ready for the pre-final inspection.
Another inspection.
Yes, this is a more formal walkthrough with the owner-designer team. Based on this inspection, they generate the final punch list. This identifies any remaining deficiencies that still need to be corrected before the project can be considered fully complete and accepted.
So, fix the final list and then?
Then you have the final inspection. If everything is satisfactory, you typically have the formal handover of keys, responsibility for utilities, and the closing down of the contractor's temporary site office. The physical work is done.
Okay, that's the physical part. What about category B, closing out the project? This is the paperwork trail.
This is all about the documentation, financial settlement, and legal transfer of risk. It's extensive and absolutely critical. It includes things like processing the final payment to the contractor, including the release of any retention funds that were held back during the project as security.
Retention, like a holdback?
Exactly. It also involves the formal conclusion and settlement of any outstanding claim issues or disputes that might have arisen during construction. Very importantly, the contractor must provide the as-built drawings.
As-built? How is that different from the design drawings?
Design drawings show how it was intended to be built. As-built drawings are revised drawings that show how the facility actually was constructed, reflecting any changes, deviations, or field modifications made during the process. They are essential for future maintenance and alterations.
What else is in this paperwork mountain?
You also need the operating and maintenance manuals, O&M manuals, for all the equipment installed in the building. Boilers, chillers, pumps, elevators, everything. Often, this includes providing training for the owner's maintenance staff on how to operate these systems, and maybe provisioning spare parts.
And warranties?
Absolutely critical. All the warranties and guarantees from manufacturers and the contractor themselves need to be collected and formally transferred to the owner. The roof might be guaranteed for 15 years, the landscaping for 2 years, mechanical equipment for 1 year.
Legal documents, too.
Yes. This is where the formal certificate of substantial completion is usually issued, which often marks the start of the warranty periods and allows the owner to occupy the building. Later, after the final punch list is done, a certificate of final completion might be issued, and this phase also formally marks the beginning of the defects liability period.
Defects liability period.
Yes. typically a period like 1 year after substantial completion, during which the contractor is legally obligated to come back and rectify any defects or nonconformities in the work that might appear during the owner's initial use of the facility. It's the final, massive administrative and contractual gate to get through.
Okay, we've meticulously walked through the 6 technical stages. Now, the focus shifts, right? Away from process and towards people. This sounds like where things often really succeed or fail. Stakeholder management.
You've hit it exactly. We shift now from the technical process largely to the human element. And overwhelmingly, the literature and experience suggest this is the primary driver of project success or, more often, failure.
So first, how do we define stakeholders in this context?
Broadly, they are any individuals, groups, or organizational units who have a stake in the project, meaning they are affected by it or they can affect its processes and outcomes, its deliverables.
And their influence can be huge.
Immense. Their attitudes, their political weight within the organization or community, sometimes their own self-serving interests. These can genuinely make or break even the most technically sound, meticulously planned project. Ignoring them is perilous.
How do we even start to categorize all these different interested parties? The source offers a matrix.
Yes, to manage this high degree of political and financial complexity, the source synthesizes a really useful stakeholder roles matrix. It classifies them into 4 major categories, based primarily on their type of involvement and their main interest in the project.
Okay, what's the first category?
The first is budgetary stakeholders. These are the entities almost solely focused on the money, the funding, the financial oversight, the return on
Who
investment.
falls in here?
Typically, this includes the primary client or employer who's paying the bills, any external financiers or sponsors providing capital, like banks or investors, and often, especially in public projects, legislative bodies who control the flow of public money and appropriations. Their main concern is the bottom line.
Makes sense. Second group.
Contractual stakeholders. These are the parties directly bound together by those legal agreements we talked about back in stage 3.
So, the owner again?
Yes, the client employer, the main consultant, like the architect or engineer, the primary contractor doing the building, and sometimes financial institutions involved in processing payments or holding bonds. Their focus is on fulfilling the terms of the contract.
Okay. Third category, regulatory stakeholders. These sound like the rule makers.
They are. These are the external bodies who impose rules, standards, permits, and oversight on the project. Think public works departments, environmental protection agencies, building code enforcement officials, maybe even general audit offices in government projects.
And their requirements are non-negotiable?
Largely, yes. And they can change, which adds another layer of complexity. You have to satisfy them to proceed legally.
And the final group, collateral stakeholders. Collateral means on the side.
Sort of. These are the groups that are still significantly affected by the project, or can affect it, even though they aren't directly paying for it or legally bound by the main construction contract.
Like who?
This is a broad category. It includes the ultimate beneficiaries or users of the facility being built. It includes critical suppliers and subcontractors who are essential to getting the work done. It can also include local public associations, like neighborhood groups, or community institutions who might be impacted by construction noise, traffic, or the eventual operation of the facility. Their support or opposition can be crucial.
Wow. Looking at that matrix, budgetary, contractual, regulatory, collateral, that is an astonishingly complex web of often competing interests and pressures.
It really is.
Now, given that most project managers, historically anyway, often come up through technical ranks, engineering, construction science, how does this matrix just scream the need for a completely different skill set? This isn't about concrete strength, it's about relationship management.
It absolutely demonstrates that the technical challenge, while significant, is often only half the battle. You can have the most elegant design, the perfect schedule, the best materials. But if you fail to manage the expectations of the regulatory stakeholders, or you ignore the concerns of those collateral stakeholders, like the local residents complaining about noise and dust.
The project stalls or fails.
Exactly. It will stall, face delays, incur extra costs, or potentially fail altogether due to non-technical issues. That sheer human and political complexity demands a rigorous, proactive relationship management strategy.
And this isn't just about being nice. It sounds like a formal process.
Very much so. The source outlines a formal 5-step process for developing this strategy. First, stakeholders identification. Who are all the relevant players? Second, systematic information gathering. What are their consistent attitudes, their underlying strategies, their potential self-serving interests? What do they really want? Third, performing a SWOT analysis, strengths, weaknesses, opportunities, threats, on each key stakeholder group. Understand their power, their influence, their vulnerabilities. Fourth, trying to predict their expected behavior under different scenarios or pressures. How will they likely react if costs overrun or if delays occur? And fifth, based on all that analysis, developing a targeted relationship management strategy for each key stakeholder's specific actions to mitigate risks they pose or leverage opportunities they present.
That moves the PM role way beyond just supervising the site. The skills needed to actually do that strategy, they sound very different.
They are. The required management skills listed are things like high-level communication, sophisticated negotiation abilities, skills in alliance building, understanding social dynamics, socializations, and even the ability to influence organization culture and build shared values among diverse teams. These are the so-called soft skills that, in reality, unlock the hard results.
And ultimately, how well those soft skills are deployed that determines if the project hits those classic success markers.
Largely, yes. It determines whether the project achieves those universal success criteria. 1, delivered on time. 2, completed on budget. And 3, meeting the goals that were agreed upon at the start.
Now let's flip it. The cautionary list of why projects fail. This feels like maybe the most profound part of the whole deep dive because it perfectly illustrates your point. The breakdowns seem overwhelmingly human and strategic, not technical.
That list, drawn from experience and research, is incredibly sobering. And you're right, look at the top reasons cited for project failure. They're dominated by management and organizational gaps.
Poor project and program management discipline, just not following the processes.
Chronic lack of executive-level support, the bosses aren't backing it.
No linkage whatsoever to the overall business strategy. It's a rogue project.
Having the wrong team members assigned. Lack of skills or commitment.
No objective measures for even evaluating success. How do we know if we won?
Insufficient or non-existent risk management. Hoping for the best.
A fundamental inability to manage change effectively when it inevitably occurs.
It's really striking when you lay it out like that. The construction teams, the engineers, the tradespeople, they usually can lay the bricks correctly, pour the concrete properly, install the wiring safely. The project doesn't typically fail because the technical complexity of building was insurmountable.
Rarely.
Much more often, it fails because the strategic alignment was missing, the management discipline wasn't there, the executive support structure crumbled, or the human elements of communication and change management failed months or even years before the technical problems became apparent. The seeds of failure are often sown very early on. #tag outro. So we've really completed the full journey today, haven't we? Through this professional playbook for managing construction. We started right at the beginning, defining what makes a project unique, that temporary endeavor constrained by scope, time, and cost, but always needed to be balanced against quality and risk.
Then we walked step by step through that rigorous 6-stage life cycle specific to construction, moving from the owner's crucial early decisions in feasibility and planning through the 3 layers of progressive design development. The meticulous tender and procurement process where risk gets allocated, into the controlled chaos of construction implementation and monitoring, and finally landing on those crucial administrative and physical tasks of the project closeout phase, where so many projects unfortunately stumble near the finish line.
And by pulling all that together, by synthesizing the material, we really identified the main consistent challenge. It isn't just about mastering those technical constraints of time, cost, and scope. It's arguably more about navigating the incredibly complex, often contradictory world of human stakeholders, and avoiding those common organizational failures, the lack of discipline, the poor strategic support, the flawed management of expectations.
It really is worth reflecting, too, that the formal recognized science of project management as a distinct discipline, it's only about 5 or 6 decades old, really. It emerged specifically out of the need to manage these truly massive, incredibly complex modern endeavors.
Yeah, that's a great point. And we've seen today, pretty clearly, that the top reasons for failure are mostly human, they're strategic, they're organizational, not purely technical or architectural. So here's the final, maybe provocative thought for you, the listener, to consider as you take this away. If the ultimate goal is to consistently avoid that failure list, which, as we saw, requires discipline, strategic alignment, executive support, good communication, what does this imply about the true, most valuable resource a project manager actually possesses? Is it the meticulously planned budget spreadsheet? Is it the perfectly optimized Gantt chart schedule? Or is it actually the deeply human ability to foster strong alliances, to effectively negotiate conflicts, and to proactively manage those complex human expectations across that entire universe of stakeholders we talked about? Something to think about. Go forth and apply this knowledge.
Okay, let's unpack this. We often talk about managing projects, right? As if it's just,